What we're going to do in this online lecture is go into what I call simple conversions. Simple conversions are one-step conversions where we take a measurement and convert it from one unit to another using one step. And you need to learn this simple thing first and get it down well, and then we'll start applying it to other things and making it more, using it in a little bit more complicated way. In these unit conversions, remember you're focusing on the unit. Your units will tell you if you're doing it correctly. It's essential to focus on the units and conversions, and you're going to find that when we use formulas later on, it's going to help you there too. Every number you write down must have a unit, and you want to do the unit math first. So pay attention to the units first, then let the numbers come. If you ever get the unit in the denominator where you really want it in the numerator, most likely what's happened is you have upside down math. You started with the unit that you're converting, one of your units you want in the numerator, actually in the denominator, and so you have to flip your entire math. And I'll go through that with you in class, show you how to correct that, and give you hints on how to start it right. All of our conversions are based on multiplying by 1. We don't ever want to change a measurement. All we want to do is change how it's expressed. We can make 1 by making the numerator and the denominator of a fraction the same. For instance, down here, b times a over a is equal to b. Why? Because a and a cancel. They cancel each other out. So if I make my fraction so that the numerator is equal to the denominator, then I multiply that times the measurement. I don't change my measurement, I only change the way it's expressed. So this equivalency statement, or my equal statement that I showed you how to get, is going to come in very handy, because if I take this equivalency statement, I can make a fraction by taking one side of the equal sign and putting up here, and taking the other side of the equal sign and putting it down here. Sometimes, though, we don't want it in this fashion, but we want it flipped. And we're allowed to flip it because 1 is equal to 1 divided by 1. As long as the unit and the number go together here, and they go together here. You see what I'm showing you? That number has to stay with that unit because it's there here. So here's an example down here. We have 4.4 liters. Notice we've made an equivalency statement. A milliliter is 0.001 liter. Now, how do I orient my fraction? I want this and this to cancel so I know how many milliliters I have. Notice liter is in the numerator here, in the denominator here, so they cancel out. All that's left is the number math, because what's left is milliliter. Now 4.4 divided by 0.001 gives me 4,400, and so I end up with my value. So always start your conversion with a measurement. Use an equivalency or an equal statement to make your fraction that we call a conversion factor. A ratio, saying 2 boys to 3 girls, can be used to make a conversion factor. Anything where it's this goes with that. Always make sure that the numerator is equal to the denominator in the factor, and that unit cancellation occurs. So let's go through one. The question is, how many microliters are in 0.004 liters? So I always start with that measurement. Now I'm going to write my equal statement. Microliter equals 10 to the minus 6. So to figure out, micro equals 10 to the minus 6. So to figure out how many microliters are in a liter, I just add liter after micro and liter after 10 to the minus 6. Now I write a factor using the equivalency statement. It can either be microliter over liter or liter over microliter. I can use either of those. Let's see which one works here. Now, if I look at this equal statement, you can see one side of the equal statement is on the top and the other side is on the bottom. or I can flip it. I can always flip a conversion factor if I need to. Now what I need to do is use the conversion factor that will give me unit cancellation. Because liter is in the numerator here, I want it in the denominator here. So I'm going to choose this as my conversion factor. Okay, this right here is just showing you one side gives you this, one side gives you that. This is the conversion factor that I choose because liters now cancel out. If I choose this, I would get liter times liter over microliter. Nothing cancels. I don't want to use that. So I do my unit math. Liter cancels liter out. I'm going to get microliter. And then I do my number math. 0.004 divided by 10 to the minus 6. If you can either use 10 to the minus 6 or you can use 0.000001, 5 zeros and a 1 for micro, and both of them will give you the same answer. You put this in your calculator and you're going to come up with, here I wrote it in scientific notation, but your calculator is probably going to say 4,000. If you're having trouble with the 10 to the minus 6, I'm going to be doing this in class. Bring your calculators to class, and we're going to do some of this math to make sure that you know how to use your calculator correctly. The majority of you aren't going to use scientific notation correctly in your calculator, so I'm going to show you how to do it. All right, so this is an example of how you do it. Now what I'm going to do is give you some problems to do. I call these you try it's. There are 3 problems here, so I want you to try these. You can either try them one at a time or do all 3. Notice I say pause the lecture and do this. You can pause the lecture, do the problem, and when you restart, I'm going to go through these step by step. Okay, so go ahead and try these, pause it, try it, and then what we'll do is go through it step by step. Here is the problem. What is the mass of an electron in micrograms? Here's the mass of an electron in grams. So I'm going to start with a measurement, and then I'm going to need a conversion factor that cancels grams out. Here's the grams. I need that in the denominator. I need microgram up here. Well, how do I get my numbers? Well, let's go to the equivalency statement. How do I get that? I use the meaning of micro, which is 0.000001. You can use 10 to the minus 6 if you want. And so I put gram after each of these, and I get this. That means I will use microgram is 10 to the minus 6 grams. And I'm going to enter that into the problem. Microgram, 10 to the minus 6 grams. Now, I see that grams cancel and I get microgram. And now what I'm going to do is do the math. I enter this in my calculator. I'll tell you how to do this, and I'll do this in class. To enter this in your calculator, you're going to put 9.101. Then you're going to press the shift key. It's a yellow key or a blue key. And then press the EE key. If you have a simpler calculator, it will be a shift and then EXP, or maybe just plain EXP. Every calculator is different. Come see me if you need help. The EE or EXP key actually puts in the times and the 10. So you don't press times before the EE. You just press shift EE, and then you're going to enter in -28. So you're never putting in 10 and you're never putting in times. Then you're going to be entering the 10 to the minus 6. Because it's in the denominator, you put a divided by. So you're going to put divided by, and then you're going to press shift EE -6. No 10, no times, because it's in the denominator. And if you press enter, you should get this number. If you're not getting this number, it's okay. Come to class and I'll help you with your calculator. All right, let's go to the next problem. What is the number of joules in 48 kilojoules? Start with the measurement. Set up your fraction for unit cancellation. And now, because kilo equals 1,000, and then kilojoules equals 1,000 joules, that gives us 48,000 joules. How many millimoles are in 1.38 times 10 to the minus 2 moles? Start with your measurement. Set your units up for unit cancellation. Mole in the denominator, millimole in the numerator. Milli is equal to 0.001 or 10 to the minus 3. So I'm going to have to put that in there. Remember to write your equivalency statement if you're having trouble getting this, and make sure this is equal to that. Mole cancels out and you get 13.8 millimole. All right, now we just did a couple of problems. We're going to be doing problems in class too. I'll send you problems by email to bring to class so that we can work through them. Be sure and do the online homework. It is worth points, so you want to get it done, but it also will help you get problems right. If you are having problems with getting correct answers after doing the online homework, do problems at the end of the chapter. You can do them before you do the online homework if you want. Then when all is done, I want you to do worksheets that are posted for this chapter. And the reason I have you do worksheets is those are going to be problems that are all mixed up. They're not in order. Some people might not have to do them, but I'm telling you, the more problems you do, the more likely you will get correct answers on your test. Problems are how you learn chemistry. It is not through reading, although reading helps you understand problems before you get to them. And it's not only attending class, it's not only reading, it's not only attending class. The key thing that teaches you are the problems. I can tell you when I was learning chemistry, I would go to class and be very confused. I would go home and read the book and be very confused. But it would be when I started doing the problems that the material started making sense. If you need help, come to the tutoring lab or come see me in my office. But realize before you come for help, you're going to have done some problems so someone has something to start with helping you. Unless you have written something on paper where you tried to do it and you made a mistake, it is almost impossible to help you. All right, good luck, and I'll be seeing you in class.